Today I'm going to be rewiring my battery box and tidying up this big mess. Hope you enjoy. Okay, so this is the lid for my battery box. When I got this battery box, it had this little gauge on it that has color lights telling you what's going on. So it says charging, flat, low, medium, or full. And it came with a merit socket. This is just a 12-volt cigarette lighter. And then on the top, I added, this was one of the first things that I added, is a isolating switch. So that's off, that's on, and you can't pull it out while it's on. So that just turns this whole battery box on and off. Pretty simple. Then on the back, I installed two Anderson plugs and a USB plug. So this just has two standard USB sockets. These, if you didn't know, are very, very good connectors. So they're used on basically every trailer, and you can get them in all different colors. Gray is the standard color, and what the different colors mean is in here there's different slottings on all the different colors, so only the same colors will fit. So gray is standard, that's why I have two, and these are very good. They can handle up to 50 amps if you wire them with 50 amp cable rated for that. They are incredibly difficult to just fall out, so they're used on fridges and all that kind of stuff. When you're going camping in like a camper trailer, because obviously you don't want your fridge coming unplugged. One other thing, or two other things, I've installed a I installed an actual voltmeter, because this thing, one, it doesn't really tell you the exact voltage, it just tells you a range, and two, if it was to say go from full to medium, it would switch over immediately, but then it would, once you take the load off, it still says medium. This tells me the exact voltage, and I'm gonna get one for the amps. Next thing I installed is this. This is a battery guard. Basically, with lead acid batteries, once you drain them past a certain point, they're dead. So 10.9 volts, if they're drained past that, they're dead. This thing stops that from happening, so it cuts off your load once it gets to the voltage that you set. And it can handle 10 amp just by itself, but it can handle 20 amp if you put it on a heatsink. So I put it on a heatsink. Now, the inside of this, it's quite a mess, so I'm going to be rewiring it. This is the main line coming in from the battery. It's fused with a 20 amp fuse, then the negative is here. And these, as soon as it comes out the isolator, the first place it goes is the battery cutoff, and the negative goes straight to the battery cutoff. This is all wired with 15 amp wire. Some of them are done a bit more because they just came standard like that, but all the stuff that I put in and the main incoming feed is 15 amp. So I have a 20 amp fuse. I'm never drawing 15 amp from this. I'm gonna get started rewiring this now. Okay, here, so basically I am just going to start by pulling out all of the cable ties and all of the wires, and I'm just trying to clear up a space enough for me to just kind of work around, easier figure out where all the cables go, and just kind of move all of them out of the way so it's a bit easier for myself. So problem I have stumbled across as I'm pulling this out, this USB over here, the negatives just come off it, spade connector. I don't have any more spade connectors, but what I do have is this random run that I'm going to chop this off and put a new lug on it, because I do have more lugs. I'll put more lugs on it, and then that can just be used for now. Okay, so here I have basically got all of the cables that I've put in out. So all of this is basically just all the standard factory wiring. So I fixed this USB cable. It didn't need to be long, it just has to go to there. So I thought I'd just point this out quickly. This is the battery guard. You can see here it's on a heatsink. Now it is plastered on with heatsink plaster, so it's heatsink thermal and it's like a glue. So that's glued on, it's not coming off. And then on the bottom we just have the battery. So these two here come straight from the battery. And then these two go out to the negative and positive on the battery box. So I'm gonna go heat shrink this on now, and yeah. Okay, so I got this heat shrinked nice and tight. So now the only exposed bit is actually less than the lugs on the isolator, which means it should not short. Hopefully, anyways. Alright, got the battery guard reinstalled, heat shrinked, all good. Now I can start actually cable managing. Okay, so it's looking pretty good down the negative side. That's kind of a bit of a mess there, but I think I can fix that maybe. But I'm thinking I'll put this sleeving over it, or I can just leave this big bundle like this. But this cable here comes from this Anderson plug. Its cable is too short, so I'm going to snip it, solder it, heat shrink, and I'll try and find some red heat shrink instead of using this blue heat shrink that I have laying here, but I'm not sure if I'll be able to. Okay, so I got it soldered, pretty solid connection. This wire, it's 15 amp wire, it's fairly thick compared to the wire I usually solder, so it does take quite a bit of heating up and it can be quite annoying. So I found some red heat shrink. It kind of looks pink, but you know, better than like yellow or black, because you don't want to get them mixed up. So I'll just feed it this on. And then I'll go from about there. The joint is just there. And then move up and we'll go to about here. Alright, so I got that heat shrinked on there, nice and secure. smartness, somehow chopped the wrong cable. I don't know how on earth I did that, but I guess I have to do it again. It's all done. We got our main positive fused, main negative. Obviously it doesn't need to be fused, but this looks a little better. It looks a lot neater here on the positive than it does on the negative. The negative still does kind of look like a mess. I probably could have put a cable tie there. The only reason it looks like a bit of a mess is because it's quite difficult to get in there with battery guard there. So what I'm going to do, I'm going to grab the bottom and the battery for this, test it out, and see if it works. Okay. Here's the battery. Just give you the specs real quick. Okay, so I'm not sure if you can read this, but it's a 12 volt, 84.2 amp hour. I believe this means it can run at around 2000 watts for 15 minutes at 25 degrees. Its nominal voltage is around 13.6. This thing has been used for quite a while, so it's almost around 12.9 at the moment. So, it's incredibly heavy. Nothing's, heating up yet. Nothing's exploded yet. I will turn on the isolator. The voltage cutoff takes a second to read and switch voltage. So you'll see this light will come on when the cutoff is on. So it's being controlled. Up front, should see voltmeter come on. It's around 12.9. That works perfect. Nothing has exploded yet. Again, nothing feels hot. Nothing should. There's no black or red on the wrong terminals. I hope you enjoyed this video. Sorry if it was a bit long, but this looks so much better. So yeah, hope you enjoyed. Make sure to like, share, and subscribe. And make sure to subscribe to see the video of me installing an inverter. I think it should be quite a fun video. Thanks for watching. See you in the next one.